Hello, good afternoon, everyone. My name is Vedant. I work at Postman, and today I will be talking about how we made Postman 60% faster. So, just to set the scope of this talk, I will be talking about the first app launch performance. So, what that means is when you click on the app opens up, it takes some time. How much time does that amounts to, right? So, that is your first app launch performance. And I'll be talking about both cold boots and warm boots. So what is a cold boot and a warm boot? Cold boot is when you open the app for the first time. Warm boot is when you have already loaded, your data is probably already on the machine. That is your warm boot. So I'll be talking about that performance. And that is a very important metric for any application. That is a metric that can churn your users if your app is slower. So just to set the context for this talk, this screenshot is from a mail that our CEO sent to the whole company. And what is written in this screenshot is that he went to Amazon and he searched the most affordable laptop that he can find on Amazon. And he bought an Acer laptop, which you will get in India around 20,000, I think that might range. And it's like a very basic machine with all these developers, especially at good companies. You will see all of them have MacBook Pros and stuff. And I also have a MacBook Pro 3. So like you won't see the performance in MacBook Pro 3, like the bottlenecks, the CPU limitations, the network limitations. But when you go to this machine, what happened was he opened the app and it took 2-3 minutes for app to open up. And that was the point where he just sent the mail to whole company that, guys, we need to fix this. Stop everything you're working on. Get this thing fixed. So this is the metric that we track the app launch performance. And like this graph represents, I'll be talking about this graph a lot more throughout this talk. How did we like measure the performance and how did we like get it down, the app launch performance. So yeah. Again. So just before I show you like how do we go about measuring the performance, some things I wanted to highlight. So the machine was taking 2-3 minutes to load Postman, and Postman is an API client. How many of you guys are familiar what Postman is? Okay, awesome. There are some people that don't know what Postman is. So Postman is a tool which you can use to test your APIs, design your APIs, and debug your APIs. APIs are basically, yeah, I don't want to go into what is APIs. Yeah, okay. So yeah, so some observation that we had, P90 metric is what we were talking about when we were talking about performance of app. P90 is what was that number of seconds that it took for our last 10% of users. Like app performance is different for every user, every machine. So last 10%, the slowest 10%, what number they were seeing. So P90, when this mail came out, was around 35 seconds. So 10% of our users, the app was taking more than 30 seconds to load. And that is a huge number. That like nobody waits 30 seconds for an app to load. And just to test their APIs, that was like really bad. And this was not just cold boots, not just that you're opening the app for the first time. It was also about the warm boots. So there was something seriously wrong. So like when this kind of thing happens, how do an engineer go about diving into the performance of an app? So let me show you what that process looks like. So this is our app. This is the Postman app for API testing. And awesome. So this is the performance tab in Chrome DevTools. How many of you have ever used this performance tab? Awesome. Some of you haven't used it. Probably I'll say 50%. So this is the best tool out there to measure your app performance. Like you can get all sort of data about the performance of your app. The hard part begins about using this tool. So let me show you what I mean by that. So I'm relaunching my app and I'm recording the profile for what happens. Your performance profile looks something like this. And this is a prod app. So this is what it looks like. there is a lot of data in this. And there are two main parts that I want to show you. One is this network part, and one is this main thread. So this network tells you all the API calls that went out. So your app is probably loading some data. So that data is coming from those APIs. And your APIs can be a bottleneck for loading your app, right? You need data to load your app. And then main process is basically showing you all the JavaScript that ran to show you that app. So these two things will tell you everything that you need to know about the performance of the app. But analyzing this from this screen is really hard. You have to dig through everything. And with the Webpack compression coming in, you might not even see your exact code here, especially on the production builds. So I have a mini version of the, I have built this small app which like documents some of the Bangalore food places. And I'll be showing you profile on this app instead of the actual production app because that is very complicated. But the ideas that we used, I will be presenting some ideas that we used to improve the performance of the app. So, yeah. So how do we analyze the app performance is the basic question. First idea that I want to tell you is that don't let your CPU sit idle. With the slower machines, the machine that are affordable laptops or something like that, those machines have CPU bottleneck. So CPU is slow, but you don't want to waste any CPU time. What I mean by that. So let's go to our Bangalore Places app and see the performance profile for this. So in the performance profile, you have an option to throttle the CPU to simulate some sort of like environment where the CPU is actually a bottleneck. And you can record the profile then. So let me start this. Okay, so this is what the profile looks like. Now, what I want to say is that we shouldn't let our CPU sit idle. What I mean by that is, if you see in this graph, as I said, there are two important things in this, network and main. Main is your renderer process that is rendering your React code, and network is the network call. The network call to get places went at this point. You can see this places call going out, right? But this time, you see the main process is doing nothing. It's just waiting for the network to call to finish. It's just waiting for that. And after you got the data, the rendering started. So you were seeing a loading screen, and then you saw the app load. So when do you make the API call? You make the API call in your JavaScript code somewhere, right? That JavaScript code comes with a bundle, and then like we are receiving that bundle, you are unpacking that bundle, and then we are making the API call. That is what most of the apps generally do. But to increase our performance, we did a trick. What if we make this API call, instead of doing it here, we do it at the start when we don't even have our JavaScript. We do it from our HTML, just writing a script tag to call that API and get the data. So the app don't have to wait. So we move this API call to this point. That's the idea. So even if before you have your chunk, you make the API calls. API calls should be made as fast as possible so that your CPU bottlenecks don't kick in. That's the first idea that I wanted to share. This is an immense, this will have an immense impact on your performance. Like you will have to do some sort of hacks to make this work. You will have to make sure the data required to make those API call is available to you already by like storing them in some sort of local storage or IndexedDB, and get those IDs that you need and make the API call as fast as possible. So yeah, I hope the idea I was able to communicate it across. So yeah, that's a really powerful idea. Yeah, move all network calls as early as possible. Yeah, if you see our actual app, like this is the prod apps thing, the API calls are happening right parallelly to the JavaScript code that you are receiving. So that both of these things are happening parallelly. So the network is not the bottleneck later. So many times I have conversation in my organization with people coming from different organization, or like various people from different backgrounds. And they say, performance, let's improve the API performance to make our app faster. And then the question you should ask is API actually your bottleneck? Or you have enough JavaScript that is compiling that you need to like parse and then render? That is actually your bottleneck. So many times your API is actually bottleneck, but you should first examine what is the bottleneck. That is the first question. You should ask like, why is our app slow? And then the answers will come. So yeah, that's the first idea. Yeah. Second idea is fairly obvious. This is nothing new. As I was saying earlier as well, this whole thing that was happening in parallel is JavaScript. You are receiving your JavaScript, you are parsing the JavaScript, and then you are basically running the execution things to render that stuff. Now, JavaScript is expensive. Just to give you an example, if you receive 170 KB of a JPEG byte versus 170 KB of a JavaScript byte, and this is done on a mobile device, like this analysis, it took 2 seconds to parse this JavaScript, then 1.5 seconds to execute this JavaScript. This is a throttled mobile summary, but the comparison will be similar. JavaScript is really expensive compared to any other asset that you fetch over network. Because JavaScript has this first you have to parse and compile it, then you run it, and both of them will take a lot of time. We know JavaScript is not the fastest language out there, definitely, but still. So when we have a company of like 200, 300 engineers, the number of lines of code will grow very, very significantly, very, very soon. Like every week, people are shipping code, and that code will keep adding up like years over years, and you will have a huge amount of bundle size very soon, because we are all building enterprise apps. We are all adding more and more features every day. So that will have an impact on your performance because JavaScript is expensive. So yeah. So reducing the JavaScript bundle is the obvious idea. Only load the amount of JavaScript you require for the initial load. And then as you require your logic, you load that chunk. So you can use this chunking and break your JavaScript into various chunks and load as per requirement. That's a basic idea. That is nothing new. People have been doing it. But something interesting happened when we were doing this. So if you see this graph, the first part, this one, that our P90 was around 35 seconds, and it was not improving. We were cutting the bundle down, like bundle was 50% down, 60% down, nothing was happening. And these are the best moments, like performance initiatives. I'll share some stories as well. It's always interesting because things never happen the way you expect them to be. So this was an interesting time. We were looking at the performance profile, all senior engineers, and like, what's going on? Like we cut the bundle. This should work. This like we preloaded the data. What's going on? And then suddenly you see that performance the load time decreased suddenly in that next version. Something we did there. And this was an interesting story. So we had this in how many of you are familiar with what is Electron? So Electron is this JavaScript library which you can use to make cross-platform applications. So when we use Electron, a lot of apps that you know are built on Electron. VS Code is built on Electron, and Slack is also built on Electron. Like a lot of apps that you use are built with Electron. And Electron has this two processes. One is the main process, which has access to like node utils, like your process and stuff. And then there is a renderer process that is responsible for rendering it. Now, we had this weird pattern, one line of code somewhere where main process and renderer process had this dependency. So from the looks of it, it looked like CPU was busy, but CPU was actually waiting for main process to finish. So this was not very evidently clear from the performance profile, but thankfully we found this bottleneck, because whatever you do in main process is going to hurt you more than the things that you do in renderer process. Main process, ideally renderer and main compete for the same CPU resource, but main process gets a bit priority. That's what we have seen. And like, so you should be very careful what kind of things you are doing in your main process. And that's what a pattern we saw, that this weird pattern is happening. So we cleaned this up, that we removed this dependency, and then we suddenly saw all the benefit of reducing all that bundle size. So this drop then came like by fixing that pattern. And this is an interesting one. This was really hard to find before the AI era. So this initiative, like all this thing that I'm telling you, happened a bit around 1.5 years ago. And AI models were good, but not as good as they are now. So I'm sure like when I was making these slides, I was thinking that if I was to do all this analysis today, it would have been much more different. I would definitely find more things. I would definitely be able to see more things by just dumping all that performance profile into Claude and asking that like questions on top of that. So yeah, but it's a very, like it's around 28 MB file and the 28 MB JSON file, which you will have to work with AI. So ideas do matter here because AI won't be able to read 28 MB that effectively. As of now, context window is still a bit limited. So yeah. So there are always plot twists when you're doing performance. So the performance, like if you see this dip, the performance improved. We were around 19 seconds of P90 and our target was around 10 seconds. We were looking very positive that we can cut the idea is working. We can just cut down the bundle. We'll get to 10 seconds. We know that we can still cut the bundle down a bit more. But then we suddenly saw that the performance got worse with a version. And like we have this performance test that we run before every version is released. So we launch our app like 100, 200 times and see like what is the numbers coming up. And then we launch a product like out to users. And we are like, yeah, this version looks good. Performance is improving. But when actually people started using it, we saw that performance metric reported from the people actually were worse. So this graph that like the tick that happened like from 20, it started going around 25. And we were like clueless what's going on. So when you're doing performance initiative, there are always plot twists. So one of the like, best blog, this is a 2012 blog when YouTube engineer was working on YouTube's performance. And like he wrote in this blog that I had decreased the total page weight. He like cut down the bundle, removed a bunch of packages. And he was sure that on his machine, the app was faster. But when he released the app, the performance was worst. And he was like, what's going on? I don't know. And then when going through the data, what they realized was that now they are seeing a disproportionate amount of traffic coming from places like Southeast Asia, South America, and Africa, which don't have that fast internet connection. The app became so fast that you got more users from places there where the app was not even working earlier. So now you were getting more traffic from those places. So the overall metric was worst. So like when you do performance initiative, you don't know what the numbers will do. Like you will have to just keep watching those numbers and try reacting to them. So in our case, what we saw was all our increased numbers were coming from Windows machines. And what was happening was one of our Webpack chunk was being flagged as suspicious by Windows because of its naming. And we had no clue what the hell was that. And we were just like, because we are not able to reproduce the issue, we just know that something is going wrong with Windows. And it's not happening on our Windows machine. I don't know like how to even debug this much like issues. But thankfully, one of our Webpack expert guy like thought that let's just like he was not even like his hunch was different when he started, but accidentally he like edited that chunk and things improved. So then we realized, oh, this chunk was being flagged and this didn't have service worker working because it was not, Windows was not letting it cache on its level. So yeah, you have to like keep trying and sometimes you don't even know what you're doing, but probably things will work. So this is one of my favorite books, Poor Charlie's Almanac. It's written by Charlie Munger. And he has this quote in this, all I want to know is where I'm going to die. So I'll never go there. That sounds like so easy and sounds like very good advice to me. Like he has a lot of these quotes, which are really good advice if you apply well. It's a book that I recommend everyone of you to read. Now that we know like our nemesis, the bundle and the performance getting slow over time, we definitely wanted to prevent this from happening going forward. We keep on adding features every day. Every day we ship. Like this whole thing happened 1.5 years back, and since then we have been shipping like again at a crazy speed. So, but we don't want to get back to that stage because performance is something which is uncompromisable. So yeah, now that we know where we are going to die, we don't want to go there. So we added some of the guardrails to ensure our performance metrics stays up. So one of the things that we use is a tool called open source tool called Statoscope. So Statoscope, what it does is it gives you analysis of your Webpack bundle. So your Webpack bundles, if you look at your performance profiles, you won't be able to see what exactly is in your Webpack bundle. And all this bundle cutting is about moving stuff out of your critical chunk. If you don't want this feature in your first screen, don't load it in your first screen because JavaScript is expensive. So that's what Statoscope report gives us. So for an example, on every PR that we raise, we get this GitHub Action powered Statoscope report, which tells us exactly what bundles are impacted by this code change. So like this change is impacting this bundle called aichat.js, and it's increasing the bundle size by 5 KB. So we get this report, and if the bundle size is more than 10 KB increased in the critical chunk, then we flag it, and the PR requires a special approval to go through. So we don't let people increase the bundle, especially the critical chunk that like user sees the request of Postman, the request tab, that should load as fast as possible. So this really helped us maintain the bundle size over time. And yeah, yeah, we also have performance test running. So every release goes through this performance test that we launch our app over like 200, 300 times and see the metric, and it shouldn't regress. That's the whole point. And even if it regress, we either stop the release or we notify the corresponding teams to get it addressed as soon as possible. So yeah, that is something we do on every release, and that's also something which helps us maintain the performance of the app. So few concluding remarks on this whole initiative. We started with a metric, and that really helped us go through this initiative well. We know what we wanted to do. Like we set a target of P90 being 10 seconds. We were able to reach around 14 seconds. We were not able to hit the 10-second mark, but target was there. And like being able to measure this consistently over every release gave us a lot of confidence that we are moving in the right direction. Sometimes we hit roadblocks and we had to like really go back to whiteboard and see what exactly is going on. But having a metric is amazing. Like this is one of the rare initiatives that can be metric driven. So performance is always metric driven, which is really good. So, but there are that's what I encourage all engineers in our team as well. If you're like working on something like improve the suggestion acceptance rate, then first thing, put a metric out there, and then over time, see if it goes down, because mostly it won't be what you expect. Yeah. Yeah, be ready for surprises. You will be 90% right, but 10% will surprise you. Your whole ideas will be right, but surprises will come. And that's why having a metric in place is really helpful. And performance is an ongoing effort for all companies, I feel. So you are never done with performance initiative. Performance is like something you need to, because you keep shipping code. So you need to ensure that the critical things don't regress in terms of performance. So yeah, that was my presentation on